Hi, we're very quickly going to construct the Great Pyramid triangle, which is really just two Kepler triangles or golden triangles, one folded over next to the other. And from this will emerge two Fibonacci spirals. These two triangles together, these two right triangles, form a triangle that has the same proportions as the proportions of the Great Pyramid. So we'll see if we can do it very, very quickly. Start with a small angle and see if I can actually make that angle a bit smaller. First, draw your vesica. And again, it doesn't matter where the second line of the vesica goes. I'm really just trying to make it okay. Now again, I don't need this straight line to be straight in reference to anything in my world around me in my physical space, but because I can just rotate my page slightly. But when I draw a line through these 2 points, I create a straight line. So we'll very quickly continue so we can construct our Fibonacci spiral. If you watch another video I'll post a link to, it goes into great detail on how to do this. I'm going to assume that you've watched that so I don't repeat myself. Remember from the other video, you're going to end up with 6 of these circles, and then we're going to inscribe the 2 central circles. I'm going to be doing above and below this time because I'm making 2 of these triangles. And 2 Fibonacci spirals. The reason my compass keeps slipping like that is because I've made the arc of the compass so narrow that the pencil lead keeps jumping on the page. But if I make the arc any bigger, then I need a larger piece of paper, so I'm trying to work with my existing paper size here. As I draw these circles, the risk of getting lost from my original 2 circles is rising. So I'm going to take just a moment and highlight the original vesica that we formed. Vesica Pisces is, of course, one of those central shapes in sacred geometry. Has all kinds of esoteric meanings. People ascribe all kinds of mystical nonsense to this, but it's just a very useful geometric tool to me. For those of you who share my skepticism about the esoteric phenomenon that are associated with all this sacred geometry, there's a word that you can use to describe your own fascination with the beauty of it, and that word is numinous. N-U-M-I-N-O-U-S, if I spelled that correctly, numinous. N-U-M-I-N-O-U-S, numinous. Okay, so that was, now at least I know where I'm going, but I'm going to continue drawing these circles because I'm going to make two triangles. And two spirals. Because my time is limited right at this moment, my temptation is to go very fast, and I'm almost certain to make some dumb mistake that will ruin this video's ability to teach you anything. So while I do have to hurry, I will try not to make any crucial errors. Okay. I want to inscribe a rectangle around these two central circles. So I'm going to highlight a few important points. As I said, I really want to make two rectangles. I may need to draw more circles now that I'm looking at this, because I need two rectangles to emerge eventually. But we'll get there. So first I'll inscribe the first rectangle. There you go. Now I need to inscribe the tops. So I need this point here, this point here, this point here, and the bottoms, and this point here. So if you've watched my first video, I'm just completing the first couple of steps of that video. Now I'm going to cut the rectangle right here in order to create those 1, 1, 1, 2, 3 shapes of the Fibonacci sequence. 1, 1, 2, and then this rectangle is 3. And now what I need to do is I need to flip this, and I need to make another one down here. So I will start by repeating what I did and make two Vesica Pisces that are inscribed by this, pardon me, a Vesica Pisces, which is created by 2 circles. And since I haven't done this before, I'm going to use the method that works, which is just to create a bunch of circles and hope that out of the chaos emerges a path forward. There's my first triangle, or my first circle, but the problem I've noticed here is that the tops of it are cut off by this this line here. I need them to be down here. How would I do that? See, that's my dilemma. I'm tempted to stop here and do something else because I want this to work. But I don't want to break any rules of the geometry of it. Let me back up here real quick. See if I can do this. If I expand my sides to be of this length here, or rather, and then I use that to make a square. See, what I'm trying to do is duplicate the image I just drew. Let's see if that doesn't give me what I want. I believe that gives me the same square, or rather the same dimensions, but I feel like I'm about to make a rookie mistake here by presuming I know where that point is. I can find that point rather easily. If I take I may have to come back to this, because I'm not really sure what I'm doing. What if I just continue with the circles? I wonder if I'll be able to see something emerge. I'll play with this for another couple of minutes and make another video. I see my second vesica there, but that's set. It's offset from. It's going to be offset by just that flower petal distance from where I need to be. So I would keep going. I need to draw more circles, I think. Because I'm not entirely convinced that this won't work. I'm just convinced that I can't just duplicate it exactly. And I may need to do the whole thing in a different orientation and make this work, but it should work. It should work. Key point. Okay. Let me just see what is available here. How can I do that? The bottoms of these petals can be used. So everything is offset by one petal distance. Is that what I'm supposed to believe? That doesn't make any sense. Oh, maybe it does make sense. I need to draw one more row of circles, and I think it will make sense. So I can use the little petals of those little leaves. That's interesting. I just have a premonition that it's not, it just seems visually too aesthetically, the relationship between that phi Kepler golden triangle and these circles seems too harmonious for it not to work. Okay, so let's reassess. I'm going to offset this rectangle by exactly this petal distance here. See, because I've got my line here, and I need this perfectly reflected on the other side. So everything is offset. It's pushed up by one petal length. So instead of perfectly inscribing two circles, I'm going to offset my inscription by a petal length down, a petal length down. So if I were just doing this exactly like I did above, I would put my line right there, and that would be wrong. I need to put it one petal length, one petal distance down. It needs to go somewhere right there. And I see that I'm not finding like a place to put that. I feel like, let me draw one more set of flower or circles and see if I've just missed something. Yeah, I don't think this is going to do it, but maybe it will. I don't want to know. So it seems like it would work, but then the idea of mirroring something, just if you draw the circles yourself, you'll see that it doesn't work like that. They overlap. They're not lined up like one against the other like that. I think this sucker's walking around. It's getting. Yeah. As you get further away from your original circle, you'll notice that you start to have these inaccuracies and you got to correct for them. All right. Okay, so first let me extend the lines down. And then let me think again. I want a petal distance. This whole thing is shoved up. So I need to find, I need a little distance there. I need the distance of this petal reflected over here. How am I going to do that? How am I going to do that? I could do it. I'm just saying, how could I do it in a way that doesn't cheat the system visually? See? That's where I need my point to be. And that point isn't anywhere. That point right there. Oh well. Let's just see what this does. I know that that's the right place. Just that the whole sacred geometry thing is lost. I'm really playing a game of reflection here. All right, well, let's just follow the breadcrumbs. Now the next question is, where does this go? Well, I get you. You know what I could do? I could do just what I did for that larger square. I could take the diameter of this small square, or the length of it, and then be very precise. Rotate it like this. And do the same thing over here. Okay, and then these 2 points right here would be the new square. Okay, So that's clearly exactly what I wanted to do, but it just doesn't look as pretty to me. But no matter, we're gonna try to rush, famous last words, rush through and draw these two reflected Fibonacci spirals and Kepler triangles, because I think I can do that fairly quickly. Okay. So I'm going to need to extend out my line here, and then make my spiral marks, and I'll do the same thing down here. As above, so below, right? And then this should be interesting. So this should be a perfect, I should be able to make a circle here with the spiral. That's cool. Put that there. Now this looks interesting. So I should be able to make a spiral shape. It's just slightly off, but I bet that's more of a result of my messed up. That's interesting. I know if I was more precise, that would be exactly right. Cool. That's really cool. That's really cool. Now I can complete my spirals. I love it. That's so cool. It's like I'm off by just a fraction down here in the bottom. That's because I didn't use the circles. I used approximation with the areas there. But it still works, and that's neat. That's interesting. So now I have two I've got two of these suckers. If I extend that out and then make my, let me make my rectangles here so I can get done. we're really close here to being done. Oh, this is cool. This is cool. I need to zoom out because you can't see the whole thing anymore. There. Cool. Very neat. I'm excited. I like it. Okay. So now I've got two golden rectangles with two Fibonacci spirals. Let's make this clear. Perfectly reflected. All right, now I need to bisect the two midpoints, and the way you do that is you set your angle equal there, and if I want to find this center point, I remember the proportion law of squares. I can cut this in half, or the diagonal rule of squares. Make little marks and cut it in half. Here's the cool part. I'll get my vertical midpoint right out of this reflection. Neat. So there's my vertical midpoint, is there to there. I'll just need to find the other midpoint for each rectangle. Now I just need to find these horizontal lines, which is easy to do once I create a circle inside these squares. So you put your pointy end in that X that you created, and then inscribe a circle inside your squares. And this is merely for purposes of finding these 2 points. Just what I'm going to do above, I'll do below. so you can see what I'm doing. Okay, we're almost done. Here's my midpoint line for this circle and square up above, and there's my midpoint line reflected down below. Now remember, we'll construct the triangle by looking at the whole thing like this. Let me zoom back in again. This is so cool. I love it. I just love it. Neat. Very, very neat. I'm just going to make some lines darker. Okay. So you see our 2 Fibonacci spirals. Anyway, I just cut the midpoint here to the diagonal. Get that diagonal. And then make my distance here. And just check to make sure I've actually got 5 proportions. And I do. I do. See, this one mirrors the other one. It's also got 5 proportions. So what I can do is just make this length phi and this length 1, 1. So this is now 2. This is the height is phi. So now I'm going to create this big triangle in here. 2 Kepler triangles that are connected. And this will be the Great Pyramid Triangle. So cool. So I'm really interested in that point. All right. Now I can make my 2 Kepler triangles. Let's make the first one that you're familiar with. You connect the diameter and then over here. And there's the Kepler triangle. That's so cool. I love it. All right. So the math behind this Kepler triangle is incredibly fascinating. The height of, we'll call this the Great Pyramid Triangle, this is a Kepler triangle, golden triangle, golden triangle, 2 golden triangles. In my other videos, I thought there was some other triangle that was the golden triangle. This is the golden triangle. This distance right here is the square root of phi. This is 1. Since these are reflected, that's 1. Okay, so they share the height together of phi. Remember, our hypotenuse is phi. So this hypotenuse is also phi. That's incredible. I'm just going to shade in a few relevant points. Let's use we'll use red here as our shade tool. I wonder, now I'm curious if this is an equilateral triangle, or what kind of triangle is it? I think it should be equilateral, but I don't know. I actually don't know that, so I'm not saying that. It'd be interesting to know. This is too cool. I don't even know what to say. Just love it. And then I'll just quickly shade in. I don't have a lot of time here, but this is too cool that you can do this. And that Kepler's triangle this whole time was the golden triangle. Well, when I figured that out, I realized, hey, I'd seen that word golden triangle before with the Great Pyramid and checked, and yeah, the dimensions were identical to the Kepler triangle. I'm just so stupid that I didn't remember it. There's much more to learn, I think, from this. What if I could turn it into a 3D object? And now we will just finish off by highlighting those Fibonacci spirals. How cool is that? That's freaking great. These are the golden sections here. There are two of them. I mean, they're both, it's just one reflected actually. And there it is. We'll call this the Great Pyramid Triangle. Very cool, very beautiful. Amazing. Hope you enjoyed this. Thank you.